So the hand unit is magnetic suspension. I have coils here. I have aluminum coil, aluminum wire. I have iron wire. I have a ball bearing bracket within the central. I have a linear motor along the side, and I have the non-coated copper underneath. That is used in the transformer as the collapsible coil. So whereas the non-coated protected wire underneath is a high gauge density, and what is covering is a magnetic wire that has a copper coating over it, a coating over the copper, and that protects the copper and synchronizes and collapses the energy within the lower coil, which is the non-coated copper, and increases the flux to the copper. Nevertheless, I have the iron. I have iron alongside coupled to the copper. And I have aluminum between, so I have copper here and aluminum and copper. I mean copper, iron, copper, aluminum, copper, iron. So each part of the copper is being phased to a magnaflux with intrusion of a ferromagnetic element. So I have a paramagnetic element and a ferromagnetic element. I linked the wire on here so that I may resin this hardened down to the surfaces. So that's what I'm going to do right now for the magnetic propulsion. Remember that the transformer may synchronize all the way to the palm of the hand. And as long as the loops, as far as the turns, synchronize and increase the voltage, because it's a step-up voltage transformer. So this is the last part of the segment that has the most energy, and I don't need that much gauge or turns for it. And it's synchronous energy, so it's not actually a DC-induced currents, and it will add a high voltage to it. However, but it would not attain that much heat because of the ampere friction is in it. It comes from a DC phase to where it's direct current and causes the pressure of the ions to move through the air. And the electron decay, which increases in the moisture in the wire where pressure bust pipes. So as long as I don't have that much pressure in the induction and I'm using synchronous energy, the synchronous energy shall not be that hot. Nevertheless, the cockpit core I have on the surfaces of the cockpit is copper, and the surfaces that's going to be on the top of here, this is not the end of the segment. This is, and it shall be enclosed with aluminum. So, therefore, the aluminum that is being phased by the electromagnetic energy, like magnetic propulsion, paramagnetic, repulsive force, because of the diamagnetic, which is the copper, that phases the aluminum, causing the aluminum to escape. So, because the aluminum is fixed permanently to the surfaces, it's going to be fixed perfectly to the enclosure surfaces, and shall move away the copper shall escape, being greater than the inertial mass. And as of the copper sheet that's underneath shall also escape, being within the magnetic field of the aluminum, the paramagnetic, obtaining a charge. So, these two charged orbital electrons that are common to one another repulse away from one another. So as the aluminum is local to the copper sheet,